All right, so let's take a look at number one. So in number one, first thing you want to do is distribute. So we have a positive 2 and a negative 1. Let me just get that in there a little bit. Both of which need to get distributed to each term within their respective polynomials. All right, so when I multiply through with a 2, in the first one, that's pretty easy. You're just multiplying, you're just doubling everything. So there's an understood coefficient in front of the x squared of 1. So that 1 times 2 becomes 2, so 2x squared minus 10x plus 6. And for the second expression, negative 1 multiplied by 3x squared becomes negative 3 times x squared minus 7. All right. Then we can combine some like terms. All right, I have two terms here, each involving an x squared. So subtract the coefficients. 2 minus 3 is negative 1. So negative 1x squared, you don't actually have to write the 1, but I'll write it this one time. There's nothing like the negative 10x, so I'm just going to reproduce the negative 10x. And then the last one is the two like terms, the constants, 6 and negative 7. 6 minus 7 is negative 1. All right. The proper way of representing the answer, though, would be without that 1 in front of the x squared. So you'd write negative x squared minus 10x minus 1. All right. You don't need to show that intermediate step, the one where I wrote the negative 1x squared minus 10x minus 1. I just did that for instructional purposes. Now, the second question, very much like what we were doing over the last couple of days. So what we're going to do is we're going to take each item that's contained within the set of parentheses and raise it to the third power. All right. So I'm looking at a negative 4 to the first. And over here I have a negative 2 to the first. And also an x to the first. So anything that doesn't have an exponent, we raise it to the first power. All right. So I'm looking at a 3 as being the multiplier for each of these exponents, and then a 4 being the multiplier for these exponents. All right, so that would be my intermediate step there. So negative, that's not a pen, negative 4 to the third, x to the 9th, y to the 12th, and then we'd have negative 2 to the 4th, x to the 4th, y to the 20th. All right. We can continue because we could figure out what negative 4 to the third power is. That's calculator work, or you just do it in your head. Negative 4 times negative 4 times negative 4, negative 64. And then negative 2 to the 4th, also, you know, same deal, in your head or in your calculator. So either way, it's going to give you a 16. All right. So then we still have that x to the 4th, y to the 20th. All right. The x to the 9th and x to the 4th, we could rewrite. I'll rewrite it, but you wouldn't have to rewrite it. I'm just emphasizing the fact that multiplication is commutative, so I could do it in any order I want. And right in the front, I'd have my negative 6, well, I guess I could write negative 16, but it's really negative 64 times 16 times 9. All right, so this is really how you don't actually want to write it out this way, but this is how you want to think about it. All right, because those x's can be grouped together, the y's can be grouped together, and the numbers can be grouped together. So then it makes it pretty clear that I should be multiplying these, and these together. All right. So actually, as it turns out, the most challenging part of this problem from here on out is the numbers. Negative 64 times 16. Because 9 plus 4 is 13. 12 plus 20 is 32. So you have that. Now, before you whip out the calculator and start crunching this, when you're thinking of the number 16, and this is something that you're going to have to do when you get into Algebra 2. I know it's a little ways away, but this mental math bit is something that's not going to be really optional anymore. So when I'm taking negative 64, I keep wanting to write negative 16, and multiplying it by the 16, we want to think of 16 as, of its prime factorization. So yesterday we were talking about what 2 to the 5th power was, or maybe it was the day before, I forget. Or 2 to the 7th power, 2 to the 9th power, how you can figure that out in your head. Well, this is the same as 2 to the 4th power. Because if you take 2 and multiply it by itself 4 times, you get 16. So what this is telling me is if I want to get the product of negative 64 and 16, I could take negative 64, multiply it by 2, 2 again, 2 again, and 2 again. Now, if you're writing this out and using a calculator, that's a waste of time. But for the purposes of mental math, it's not, because it's one of the easier things that you can do in multiplication is doubling. All right, that's actually, and my son's going through it now. He's in 4th grade. He's going the other way. He's learning about roots and things like that. But it's all relying on his knowledge of powers, right? So, it's this. But when he was learning about multiplication, the first thing that he was learning about is like, all right, we're going to take a quiz on your times 2, multiplication tables, but just the multiplication by 2. And we're like, what the hell is the purpose of that? Like all you're doing is doubling. Oh, that's how important it is. All right, so if I'm looking at this, I would say, okay, I'm going to double this. That's going to give me negative 128. Then I'm going to double this, negative 256. And I'm going to double that, negative 512. And then I'm going to double that, and I get negative 1024. All right, so, if you reflect back to your elementary school experience and you think about all those stupid Common Core worksheets, air quotes stupid, what they were trying to do was they were trying to manufacture that way of thinking, right? But the problem is, how do you legislate creativity? Like if you were to walk into an art class, you would probably think you're either creative or not, right? So there's some people that walk in and they can sketch a portrait and have no problem, and then there's other people like me that go in and be like, all right, I don't even know what to draw, and if I did, I wouldn't know how to do it, But what they wanted to do with Common Core was come up with a curriculum that would get everybody to the same place. So if you take this class, you would learn to be creative, and in this process would teach you number sense, right? So either it worked or it didn't, but you should, at this point, if it did work, be able to figure out something like negative 64 times 16 in your head, right? Just by doubling, right? That being said, you have calculators. So there's no reason why you can't use that calculator on this level, but there will come a point in time where your number sense or lack of it will either be, an asset or a hindrance. It's the same idea with like vocabulary in other classes. You take the time to learn different forms of vocabulary. On certain levels, it doesn't really make a difference. But then when you get to higher levels, if you don't know some of the terminology, you're sitting in an AP history class, you're like, I don't even know what the words mean, So it's the same idea. All right, so I'm just gonna do one problem here because this whole section, 16 to 18, is very similar to number 1, except instead of running through with a constant, we're running through with a variable expression. So let me grab something kind of juicy. How about number 6? So we have an expression on the outside of a set of parentheses, implies distributive property. The reason why distributive property is relevant here is because there are addition signs within the parentheses, right? So imagine the problem is almost exactly the same, except there are no plus signs, right? It was this equals that times that times that. And you know, you have different variables like y's and z's, right? That would not be distributive property. You don't multiply this by each term, because they wouldn't even be terms if these were multiplication symbols, right? You would consolidate what's happening inside the parentheses first and then run through with whatever the multiplier is on the outside. But because there are plus signs or minus signs, not negative signs, but minus signs, right? Plus signs or minus signs within the parentheses, that's indicating that the distributive property needs to happen. All right. There's some folks that are like, yeah, I know, duh, stop talking. But there are enough people that will screw that up on the test that it's worth talking about. All right. So I'm going to take this and distribute, because people just want to distribute. You see parentheses, I got to distribute. It's not always the case. You got to think about it. All right. So distributive property because of plus minus. All right. So again, this is addition and subtraction. All right. Not positive, negative. Just because you see a negative sign in there doesn't mean it's distributive property. All right. So I have to take negative 2/3 x squared and multiply it by negative 9x squared. I'll write the actual steps. And then we're going to add to that negative 2/3 x squared times 3x. Then we're going to add to that negative 2/3 x squared times 6. All right. This, what I just wrote, is an unnecessary step. It's the only time, bless you, the only time I'm ever going to write it. All right, because these are steps that you would want to be doing on the fly. You don't want to have to write this out every time. Besides, if you're anything like me, the more things that you have to write down, the more likely you are to screw up something. Right? Like you've seen my typos. So, but at least here I'm indicating at least the one time that I'm taking this, multiplying by that, that, and that. All right. So we'll tackle the variables first. Variables are easy. All right, keep the base, add the exponents. They're easy as long as you know the rules. Understood exponent of 1 here. Keep the base, add the exponents. There is no x associated with the 6 here, so it's just the x squared. Bring it down. All right. The numerical values, a little bit of a different story because there's fractions. But I do see I have two negatives here. That's going to give me a positive, so I'm not going to write a sign there. A negative and a positive is going to give me a negative. A negative and a positive, also negative. All right. So now it's just a matter of tackling the numbers. Now, don't get intimidated by fractions. That's a directive. You're not allowed to do that. All right? Because people, they look at the fractions. Yeah, I'm going to go to my calc. How do you type in a fraction in calc? A fraction is just operation. There are two operations. All right? It's multiplication and division in the same operation. It's telling us to multiply the number by 2, then divide by 3. Or it's telling us to divide the number by 3 and then multiply by 2. Whichever is more convenient. Personally, I like to scale down before I scale up. Right? Because I like to think, well, if I can make the number simpler, it's probably going to be easier to compute in my head. Right? So if I'm multiplying 2/3 by 9, I'm going to take that 9, divide it by 3, which makes it 3, and then multiply by 2, which makes it 6. Right? I'm going to take this 3, divide it by 3, which is 1, multiply it by 2, it's going to give me a 2. All right. You could also think of it as, well, it's 2/3, so break the number into thirds and just take 2 of those thirds. But that, That only works with the nice fractions. So I'm going to take the 6, divide by 3, you get 2, multiply by 2, and you get 4. All right, and since the signs were already taken care of, I don't have to worry about multiplying by a -2 because I already accounted for that. Right, but if you didn't, you'd have to multiply by -2. All right, but that would be our simplest form. And you know, you look at something like this, and it's kind of surprising that from this mess you have this kind of clean-looking algebraic expression. And that's a lot of what we're going to be doing for the rest of the year. We're going to be taking expressions that are kind of nasty and trying to figure out different ways in which we can clean it up, right, for the purpose of using it for applications. All right, anyway, so I've blabbed on it.